Hey guys, welcome back to Andy's Corner HVAC. I'm glad you joined me today. Today I want to talk a little bit about geothermal heating and cooling. Geo is out there all over the place, and geo is not new. It's been around for a very, very long time. So, the idea of how it works, I've figured out that a lot of people don't quite understand it. They don't understand how it works, what it does, why it's better, all this kind of stuff. I've been around the geothermal industry for about 24 years. But geo has been there for years and years. Everybody keeps saying, well, this new geothermal technology stuff, I don't know if it's going to take off. Well, I hate to break it to you, but it took off a long, long time ago. The idea of geothermal has been out there for years upon years upon years naturally. And then as far as, heating and air guys being able to harness that energy and put it into heating and cooling systems, I mean, it was out there in the 70s and 80s. It did become more mainstream back in the 90s, but on through the 2000s, they really revamped everything, and it does awesome. So it's not new technology by any means, but it's out there all over the place. But I am figuring out that a lot of people don't quite get how it works or what it does. I was talking to some people today and they said, well, I get geothermal. I understand how it works. I have a geothermal. I get it. There's loops in the ground. The ground is always a certain temperature so far down and that water goes through there. They said, but the thing that I don't get is how do you take that 50-degree water, pump it through the house, blow air across it, and you make my house warm? And I sat there and thought about it, and it's like, I've heard this story before many, many times because a lot of people do believe that that's how it works. Yes, once you get down below a certain depth in the ground temperature is the same all the time. Geothermal does move water through loops that are in that ground to change the temperature of the water, and then that water is brought into the house. But one of the big things that happens with that is there is a refrigerant circuit inside that unit, and that's what the water is actually for. The water is there to be used to change the state of the freon by changing its temperature within the coax. The coax is a large piece that's in that geothermal. It's basically a pipe inside of a pipe is how I explain it to people. There's obviously a little bit more involved in that now, so all you technical people out there that are watching this want to know all the specifics and all that kind of stuff. There is more to it than that, but this isn't a full education lesson. I'm going to tell you every little piece, part, and thing that there is to it. But we're moving that water through that coax, and what it does is there's a freon line that is basically wrapped around that other line as it goes through a coil in there. And as that freon runs through there and that water runs through there, the freon can change state by the temperature of that water. In the wintertime, we were pulling heat BTUs out of that water and changing the temperature of that freon. And changing the temperature of the freon, it will start to change state. Just the same as in the summertime, that freon that's going through there, that water will be cooler, and it will push those heat BTUs into the water to be able to go push it back into the ground. The reason those loops are in the ground and it constantly circulates through there anytime that the unit runs is because, yes, the ground temperature is a certain temperature once you get so low. Now, every area is a little bit different. So if I say numbers here and you start screaming and yelling that I've got the wrong temperatures at the wrong depths, all that kind of stuff, keep in mind that it's different everywhere. So what I use for a basic rule is I say 6 foot down, it's around 55 degrees. That's rough. There are different areas that have exact number of inches down with exact temperatures and all that kind of stuff. I don't like to get too fine lined into some of the details trying to explain this kind of thing. But so I go with once you get 6 foot down, we're about 55 degrees. That's relatively true in most areas, or at least good averages, anyways. So once you get down that far, that temperature of that ground stays the same. So when that water comes through there, and let's say in the summertime, we are pushing heat BTUs from the refrigerant into the water, that water is then moved out into the ground. That water is going to get warmer and warmer as the refrigerant keeps pushing heat into it. That water goes into the ground, and as it goes into the ground and goes through all those loops and all that piping and everything that's out there, it will actually be able to cool the water back down because the ground is colder, or a little bit cooler anyways. So we start dissipating those heat BTUs from the water, first from the freon, to the water and then from the water to the ground. So at that point, the water can recoup some of that natural temperature and bring it back in and repeat the cycle all over again. Now, there is some chemistry lesson that happens there as far as that BTU transfer and transferring from one place to another place to another. But we're not, like I said, we're not going to get too fine lined into all that. But the main moral of the story to remember is that that water is changing the temperature of the freon, which changes the state of the freon. You know, is it a vapor? Is it a gas? Or I'm sorry, is it a gas or is it a liquid? You know, what state is that freon in at any given time in that circuit? You know, heat pumps in general have been around for a very, very long time. And really, a geothermal is nothing but a heat pump. Actually, a geothermal is classified as a water to air geo. They do make water to water, but the majority of what we see is water to air. But, you know, air source heat pumps have been around for a long, long time, even longer than we've been using geothermal in homes. Now, like I said, geothermal's been out there a long time, but as far as being able to heat and cool your house with it, you know, that's in the past 40 years or so that it's really been 30 years, 40 years that it's been mainstream. So, but air source heat pumps are using the air outside to change the temperature of that freon, which changes the state of the freon in order to heat and cool your home. With a geothermal, we're using water to do that. The one good benefit about the water and what makes it so much more efficient is the fact that the water in the ground is a constant, stable temperature. With an air source heat pump, the air outside, it's all variable. It depends on what temperature it is outside, if that coil's wet because it's raining or maybe it's snowing or, you know, whatever it may be. You know, air source heat pumps are very, very efficient at that 30, 40, 50 degree mark. But once those normal heat pumps get down into, you know, 15, 10, 5, or even 0, they start losing efficiency. Now, I know there's a bunch of heat pump geeks out there that are going to start yelling at me that heat pumps can produce BTUs down to negative 27 degrees. And yes, I agree with you, they can. But the other thing is, everybody looks at air source heat pumps these days and look at mini split systems. To me, a mini split system is not a traditional or conventional heat pump system. It's completely different because it's not a true split system with ductwork on it. And yes, they can produce BTUs down at very low temperatures. I agree with this 100%. But the number of BTUs that they generate are less. So at that point, you start losing capacity. So that is my little disclaimer in there for all you heat pump geeks that want to start yelling at me. I'm not knocking heat pumps of any sorts because I do love heat pumps. I think they're awesome. I work on them all the time. I think they're great pieces of equipment, but they do have their limitations, especially air source heat pumps. Yes, they will generate BTUs down low, but they do not generate as many BTUs at 0 as what they do at 30 degrees. They lose capacity. So now a 3-ton Geo or a 4-ton Geo is no longer a true 4-ton Geo. Now it's a 2-ton Geo, something like that. So, you know, that's how that whole capacity kind of thing works. And so I wanted to throw that out there. But as far as the heat pump in general, that's what it's doing. We are using either the air in an air source heat pump or the water in a geothermal heat pump. We're using that to change the state of the freon. The freon then goes on through the rest of the refrigerant circuit, which I'm not going to go through the whole breakdown of how a refrigerant circuit works. I actually may do another video out there. Let me know in the comments if you're interested in that. Because sometimes if you're not really into this line of work, people don't care about the refrigerant circuit, you know, what state the freon is at any given time in the circuit and all that kind of stuff. But if you're interested in it, let me know because I would love to do a video on that. I do that at work. I do trainings on the refrigerant cycle and I love talking about it, but not everybody wants to hear that. It can get boring sometimes. So, but that freon is going through there and that's what we're doing. We're just using the water to change the state of the freon. The freon then goes through the entire system. By the time it goes through an expansion device, or a metering device of some sorts and goes into your indoor coil, that's where the coil is actually getting hot in the heating cycle or it's getting cold in the cooling cycle, and then your blower is drawing air across it to pull that temperature off of it to move it through your ductwork and into your space and into your house, all that kind of stuff. So that is how the water is actually working in a geothermal. You know, there's so many slogans out there about, you know, heat with water when you're using geothermal. Or I used to have a T-shirt that said "All my friends heat and cool with dirt," and it was a geothermal advertisement. I thought that was really cool, but when you wear that, people don't get it because they just don't understand how 50-degree water or 55-degree water is heating or cooling your house. But that's my whole point, is how that water circuit actually works in the Geo. So again, Geos are awesome. They serve all kinds of purposes in all kinds of places. They are the supreme equipment as far as efficiency. To date, is no other HVAC system out there that can compete with a geothermal as far as its efficiency ratings. I know there's people are going to jump up and say that there's new mini splits that can do that. That is total bogus. Because you can look at your SEER ratings, your EER ratings, and all those different things, and the math does not add up. Yes, heat pumps do awesome. Mini splits do great as far as the low temperatures and all that kind of stuff, to an extent. That is the biggest thing, is to an extent. And geothermal does not have any extents. If it's a 4-ton system, it'll be a 4-ton system no matter what the temperature is outside. So that is why they can always overcome a mini split, or even a side discharge, or an inverter compressor in a heat pump, or anything like that. So they are still the top notch. They are the best you can buy. The price tag is up there on it. I've got another video out there on why does a Geo cost so much. I may do some new videos on geothermal, because I've been talking about it at work with some people, and I love Geo, and I just want more people to understand that. And there's reason behind the higher cost of a geothermal. It is a high end. But it is absolutely worth it. So if you have any questions, or you got any comments, or if you're one of those heat pump geeks out there that want to try to prove me wrong on as far as some other piece of equipment is more efficient than the geothermal, because I'm waiting for those, because I just know they're going to come. And actually, I love those kind of comments, and those kind of conversations we can have and everything. So feel free, hit me up with whatever you got. If you have any questions, if you got any complaints, whatever you want, hit me up on the comments. Otherwise, be sure to subscribe, like, and share, and do all that kind of stuff, because sharing is caring, and sharing with your friends is just the right thing to do. I mean, you know how it works. It's YouTube. We all ask for this kind of thing, and it really does help. So, interact with me a little bit, and we'll see what we can come up with. Thank you, and God bless.